Morning, guys. I'm Bill Howard, and this is Scott Nelson. We're with Hollabaugh Brothers. We're the A.L. Smith representatives, and Scott is the water heater expert, so he's going to tell you everything you want to know about the heater that you have in. And then we're going to go down to the mechanical room.
Bill is the territory salesman, so his card is in your packet. If you have any questions in the future, he's down to Eugene at least two, 3 times a month. We have a local service agent, but the service agent on this is going to be Hydrotemp. So if there's something that goes wrong with the heater, there's an 800 number on the heater to call A.L. Smith direct, or you call Hydrotemp and we'll get you taken care of. The product that you have installed down there is manufactured by A.L. Smith Company. And it's our Cyclone XI model. The Cyclone XI model is our best tank type water heater. So it's a tank type water heater. It has 130 gallon storage, and it has a 500,000 BTU input. So it's quite a hot water making machine. The Cyclone series is 96% efficient, so it's become our most popular water heater because it creates 17% more hot water than the standard tank type, and it also is much easier to install. If you turn to the first page, a couple things you'll note is where it shows that control, which we'll go over during the training at the unit. That is a very nice control for the maintenance guys. It allows you to control all the functions of the water heater, the differential, the set point temperature we'll go over. It has a pretty good diagnostic system that speaks in English as opposed to error codes, and it saves information. Some of the original water heaters that had diagnostics in them, the second you turned them off, all the data that was collected on that unit disappeared and you started fresh. And you'd have to remember the error code. This saves in the module all the operating characteristics, any faults, anything that's gone wrong. And if something does go wrong for troubleshooting, it tells you what to look for. To give an example, I've been in these situations before to start up a water heater, and you hit the button to start it up, and all of a sudden it doesn't start, and you have people as yourself around. Well, I had a problem where one guy had actually knocked out the lower temperature probe. During construction, they pulled the wire out, so the wire was unplugged, and it told me, lower temperature probe wire unplugged. They plugged it in, I looked like a genius. I fixed it right there. So it's a very easy to work control, and we'll go through the control out there. The unit is a powered unit, so it has gas coming in at the top. It has a blower fan, so it mixes that gas and that air in the proper proportions and forces it down from the top of the heater down through a coil heat exchanger that's inside the heater. So all the air is forced through that coil. It allows you to get as much hot water, and then it comes out the bottom and exhausts out. There's really nothing to service on the blower. It's all enclosed. We'll talk about maintenance schedule when we're down there. There is a video on how it's made. Has anyone seen the show How It's Made? They actually have a video. They have an episode on this heater from A.L. Smith, so you can actually go on and see how the heater's made. This unit does have powered anode rods, so if you're a water heater geek like me, there's always maintenance required on anode rods. An anode rod is a material that you put in the heater. It's either magnesium or aluminum or zinc, and it sacrifices itself so any bare steel on the tank doesn't get corroded. So you have a glass lining, which is ceramic frit baked on, and then if there's any impairment of that, the anode rod protects it. So you'd have an anode rod maintenance dependent on your water, and you'd have to go in annually and change the anode rods, and that would ensure your tank would last longer. These are titanium powered anode rods. There's really no maintenance. And if something goes wrong with the anode rod, and it's usually wiring and not the anode rod itself, because the titanium should pretty much last forever. It tells you about the anode rod. So powered anode rods, no anode rod maintenance, they should last the life of the heater. Multiple venting options. I haven't seen the unit down there, but venting is pretty critical on these. And we'll talk about that when we're down in front of the unit. Very innovative, trouble-free product. Safety features. There is a maintenance schedule in here we'll go over. It's either semi or annual maintenance. It's flush the tank annually, which I'm sure you've done on all your projects, and unlime it semi-annually or annually, depending on the water condition. In Oregon, our water conditions are pretty darn good, but there's like places in New Mexico where after a year, that thing is limed up inside. That doesn't truly happen here, but it's something to be looked at and maintained. Safety features, there's some redundant safety features on the unit. On the top of the unit, all the mechanics are at the top of the unit. From the bottom down, it's pretty much a tank type water heater. The top of the unit has various pressure switches that monitor the intake air. For example, if your intake air got plugged, there was no air getting to the unit, say a bird nested in it, it would shut the heater down, block intake flue. It monitors the flue gases out. If the same thing was to happen, you were to plug up your flue, it would shut the unit down. And then there's the traditional safety device that every water heater has, which is the TMP valve, and there's a maintenance schedule recommended for the TMP valve. That's the temperature pressure relief valve. It's in the top 6 inches of the unit. If the temperature gets too high in the unit, or if the pressure gets too high, that blows and keeps the unit from blowing up. So
basically, you have a time, like a 2-year or something, change the TMP valve, or just change the valve out, or is it maintenance?
if you look at after the feature function benefit of the heater, we've attached an O&M manual, and on page 61 of the O&M manual is your table 14 is your maintenance schedule. So TMV valve, you should test semi-annually, and if it's operating, they don't really go bad. So there, it's pretty simple from a maintenance standpoint. Sediment removal, lime removal, inspecting the anode rod to make sure they're clean, and testing the TMP and checking the vent system. And we'll go over all that at the job site. There's also complete troubleshooting guide in here. On page 59 will help you interpret any of those messages that you get. It really takes care of itself.
Somebody shut off the gas yesterday. I think one of the guys, they put covers on there, and once we turned the gas back on, it just pre-fired and it was back and running.
And when we go look in that control, it will tell you how long the units ran, how many times it's fired. It will tell you, it will have that fault on record, that low gas pressure will be in there, so you can go at any time and look at the unit and have a record. That's the key. You have a record of how it's been operating. So it's real easy to diagnose things like that. There is an 800 number on the unit. If you would call Hydrotemp if anything went wrong, but what Hydrotemp would do would be to call that 800 number, and then they would ask for a serial number, and that would give a record back at the factory of that would pass through people and through the years that would be attached to that unit. Because whenever you call the factory, they're going to ask for the model and serial number. I'll show you where that is, and they're going to plug it in. It's going to have a history back there at the factory. They've been doing this a long time. It's pretty. It's a water heater. I'm sure your training's on boilers and some of this. You have rainwater here, probably a little more intense, but this is a pretty simple training. So if we can just go to the unit and then I can answer any questions at the unit. Okay, guys, you've got 2 units here, 2 A.O. Smith cycle water heaters. They are plumbed in parallel, which means that these units will draw equally. So one on, both on. You're going to draw the system out, so that allows the heaters to kind of have equal lives, so they last longer that way, because one's not doing all the work. This is your temperature and pressure relief valve. It is the main safety device on this unit that protects you if anything should go terribly wrong and the controls weren't to work. This would prevent energy from being stored and causing any issue. If you pull this, it lets the hot water go down there. You can check that annually. The units are identified by this little tag right here. This is the manufacturer's tag. On this tag, they have the model and serial number. The first number on here is a BTH 500A, and then it's a 104. That last 3 digits on that number is critical, because when you go to the website to get the O&M manual, there is an O&M manual that exists that would say Series 100. So you have the newest model, the latest technology. So this is a Series 104. So whenever calling and talking about this unit, that 3-digit number becomes important. Under that, or next to that, is a serial number. The serial number will tell the manufacturer where it was made. This one was made in McBee, South Carolina, the year it was made, and the month it was made. So it's just like a car, you know, as time goes on. So whenever you're wanting to, if you have any issues, you want to have the model and the serial number, they're right there on that tag. These are the danger warning, and basically they're both written and visual to tell you not to store gas here. You know, very, very important. The workings of the unit are all up above. The only thing that you would ever access down here is the handhold clean out for maintenance if you're going to look inside the unit and check for sediment. To drain the unit, there's a process in your O&M manual. The drain valve for this unit's right there to flush it out and drain it. You've got your incoming gas here, and you've got an aftermarket regulator that's not part of the A.L. Smith system, but we want each of these to have their own regulator, which they do. And then the gas goes into the gas train, which is up on top of the unit. There's a blower up there. There's 3 pressure switches. One of the key maintenance points is on this exhaust vent. Does everyone see this little clean out T down there? Imagine if that clean out T was to somehow get clogged up, because these units are 96% efficient, so they make a lot of condensate. So if the condensate could not drain out through that T, the condensate would start filling up this pipe. And once it gets to a certain level in that pipe, it's going to say block flue, it's going to shut your unit. So, you know, depending on how long it's been running and you know, what can get in there during construction or long term, that's a key maintenance point there. A lot of times if it's block flue, you just drain that, and some PVC shavings will come out, and off you're going. Well, the heart of this unit is the control, and the control is, if you see there's a button here that says menu. If you hit menu, it's going to give your different things you can go into. The first one is temperatures. So if you select temperature, you'll see that the operating set point on this is 140. So this unit is making 140 degree water. 140 degree water can burn people, so my assumption would be that there's a mixing valve somewhere. Does everyone get that concept? So,
the mixing valve is right here around the corner.
So that's allowing only 120 to go out to the units. The next thing on here is a differential. And if you were going to change any of these, you'd hit change. Say you want to hit change on the temperature. Now I can move the temperature up and down. Okay?
And we do have a kitchen loop off of this, so you only want to set that to 140.
So the second unit on this is the differential. And that's what that does, is that lets you somehow manage how the heaters operate. The differential takes a temperature reading off the top and takes a temperature reading off the bottom. And this is set at 8 degrees. So if this heater reaches 140 and it's satisfied, it's not going to turn back on until it drops 8 degrees. So it really won't fire back up till it's 132 inside that temperature. Depending on your usage, the larger the differential you can get away with, the less the controls actually have to go off and on. I mean, they're tested at 5 million cycles or 500,000 cycles. So if you had, say, a 2-degree differential, these things heat up pretty fast. The heater would come on, it'd go on, off. So an 8-degree is okay, but if for some reason it's not getting done, you can change that either way. And it'll tell you how it's computing that.
Can I ask you a question about temperature?
Yes.
Is it set at 140 because of code? Because it's connected to the
Kitchen. Well, it's the way it's designed is the kitchen loop needs 140
It needs 140
for your dishwasher and for sanitizing.
So when you
You could, and then you could put this down to 120.
Yeah,
But your mixing valve's doing that for you.
yeah. The point is energy saving. You know, yeah, 20-degree.
Yeah, you want to keep them in the condensing range if you can.
And what is that?
What is the condensing range on these guys?
they'll condense from anything above, at room temperature, so from 90 to 140. Yeah.
So that's part of the 142. It's
Yeah.
in its condensing.
Yeah, that's
So
within its range.
If we did put a booster in the kitchen, located that in the kitchen, we could keep these at 120.
In
In theory,
yeah,
And would they?
it probably wouldn't save you any energy.
Really?
Yeah.
yeah, it really would.
There's two schools of thought, and to put them one way, you have the lawyers that would like to see it at 98 degrees, because so no one could ever get burned, and you like the health people that like to see it at 140 because that would be more likely to kill any Legionella or anything in there. And there's theories on both sides. Either way is fine, but 140 and mixing is the strategy I would probably use, just because it's
You are, I mean, if you think about it, nice, warm, moist grows bacteria.
Right.
Above 132, if I remember
Yeah.
right, is where you kill bacteria.
yeah.
So you're keeping this above that line.
So when you're done with the menu, you go back. The next menu on here would be the heater status. So you can select that. It's going to tell you the status of all the switches, whether they're opened or closed, and that you can refer back to the book. Here's where you can change the display settings. You can change the contrast. You can put it in a different language. You could make the light so it goes on all the time, or for energy savings it goes off. So you can play with that. Here is the heater information. So this heater has actually been on for 168 days, 2 hours and 0 minutes. So it tells you how long the heater's been in operation. It also tells you of that, the burner's been operating 17 days, 12 hours, and this heater is cycled 18,000 times. So you could look at this heater and that heater, see if they're operating the same. Check your cycle counts. You can get a good idea of how the heater is operating. And then current faults or none, it'll show you the current fault. And then it'll have a fault history here. And it'll tell you the faults, and you've had some low gas pressure faults 20 hours ago. Okay, so 20 hours ago, something happened to the gas of this heater, and it tried to fire 3 times, because it will try before it goes into lockout. These things, you have heaters that will try once, then you have heaters that will try multiple times. The one time from a maintenance standpoint is kind of a pain, so, it tried to fire 3 times, and then more than likely it went into lockout. Someone had to come down here and hit the button. So they hit the button, it turned on and off. There is a help button on here. So if you have a fault, you push the help button, it will explain that fault. So it's really a little mini O&M right there on the unit, which is pretty cool. When the heater fires, there is a visualization of the sequence of operation. So the little thermometer says, I'm calling for heat. I'm cold, I want heat. the fan will go on, the blower will go on, and it will go on for 30 seconds and purge any gas or air that might have been left over from before. Then it will, the little igniter come on, which is a little glow stick in there, and once that's proved that it's hot and ready to go, it'll open up the gas valve and the heater will fire and you'll see this little flame. So everything that's happening within the unit, you can visually see right there on the unit. And I've sat and watched that movie many times. This cowling is just artistic display. I mean, it doesn't affect the operation of the heater other than having the actual thing in it. The powered anode rods are up top. There's two of them. All they are is the titanium anode rod's about that long, and it's a little wire.
It is worth noting, guys, that these are over 199. So by state of Oregon, they're considered a boiler. They should have already mailed you guys your permits. So I don't know your guys' process for that, but they should go to your central office.
I haven't seen them yet.
You haven't seen them yet? Okay. If you don't see them within the next couple weeks, I'd let Riley know and he can get a hold of me and we can go through the state. But you should get your permits sometime soon here to post on them. Same for your boilers, your tanks, everything that's over 199. You'll have quite a few in this room.
These are also ASME model heaters. In the state of Oregon, if you're over 109,000 BTUs, you have to be ASME tank construction. That's a construction code that ensures that the welders that welded the welds were certified, and there's a whole inspection report. It's a quality control standard. They do make this model in a non-ASME, and if this went bad and you were to put a non-ASME in there because it was less money, it would get flagged because this is an ASME state.
Yeah. So you'll have your annual inspections. I'm sure you guys are accustomed to.
In your O&Ms are step-by-step procedures on cleaning and flushing, unliming, checking the TMP. There's a troubleshooting guide that explains the error codes. There's a section on how to program. If anyone wants to get up here and play with the control, I encourage it. It's fairly simple. The difficulty comes in is you're in a menu and you want to get out of it. Do you push update or back but it's not. So you might hit the wrong button a couple times, but you figure it out pretty quick. This strapping is probably your seismic requirement in case a giant earthquake hits Eugene. We don't want them to fall. Gas shutoff valve would be right there. Your gas shutoff valve, and probably those are emergency shutoffs up there. Shut the electricity off the unit, or are those
are the disconnects for the units.
Okay.
And then you have your, per boiler code, you have your gate valves in and out. You also do on the condensate side, you have your condensate neutralizers that you'll want to check probably a couple times a year, and you'll get into a good feeling of, how often those need to be replaced or refilled. Those are the refillable
Sorry
type.
for not knowing this, but what is that?
It's basically a plastic tube that has on the back side, there's a clean out with a square nut. So you can take that out, and then it has limestone chips in there that neutralize the acid because your condensate's acidic, and we can't dump that to drain.
Okay.
So basically, over time, those limestones will dissolve away, and then you need to replace them with more.
It just comes in a little packet?
Yeah. Usually, you can buy a 25-pound bag of limestone chips, and you'll, keep it tucked away in a corner for these, and then your boilers also have them.
Now, is that in this manual as far as the maintenance thing? Or is that
No, that's a separate item.
Yeah.
It's but you'll want to do it as part of your maintenance of the water heater. It's kind of like the gas regs. They're not part of the water heater, but it's associated.
The condensate's typically as acidic as a can of Coke. So there's people that say you don't need to neutralize it. There's people that say you do, and I think Oregon now you do. So the controversy solved.
State mandated.
Any other questions, or
And there is, just so you guys know, kind of a between now and then. There is another training on the solar side of this, and it's basically, this is your gas water heaters, this is your solar. This does tie into your solar. We'll get into that later. But this is your over temp. If the solar ends up overheating the system, it's got a couple stages, but it'll basically discharge heat to the condenser water loop. And then if somehow that's not keeping up, this acts like a really big TNP on that control valve up there. It'll just dump it before it scalds anybody.
Off to the solar system.
Correct. Well, it's tied to the solar. That's the reason. But these have a very tight control.
Right.
The solar is, we've got sun.
Right.
I believe this is the actual solar valve. Right here, yeah, that control valve.
So,
Expansion tank is, you know which one is the water heaters?
Well, you've got a domestic side, a solar side.
Another thing to note, and it's in here, is as you heat water, you guys all know that it expands. Okay, if there's no place for it to go, a lot of power, it crushes things. There's built-in expansion here, and you know,
I think it's the left-hand one.
it's one of these nice tanks out there. I'd have to do the plumbing. And is that your storage tank?
Yeah, we've actually got two storage tanks, one for solar, one for hot. This is your hot.
Yeah. Oh yeah, this is us. This is his AO. That's
Yeah,
the
they're both AO.
Yeah.
Yeah, this one's insulated inside,
Yeah.
but we're basically, you want to take advantage as much as you can. It basically adds capacity to the system by having the storage tank. And then on the solar, same thing. You want to take advantage of that because, you know, during the winter, it gets dark at 5, 6 o'clock. All the students are taking their showers at 7, 8, 9 o'clock. So you want to be able to store that heat in an insulated tank and then use it when there's no sun.
So that's this one here is for the domestic.
Yes. They're both domestic. This is for the domestic hot water, gas hot water. That's for the solar.
And then they mix. Would they mix?
Eventually, the solar feeds into the domestic, and then they both go through the mixing valve.
Okay, it goes right into the domestic tank.
The solar basically preheats the gas water heating system. The point of the solar is to make so these don't have to run. That's how you save them.
So it's a thermostat that controls it.
On the solar,
Yeah.
it has some sensors tied into the DDC on the pumps. So when there's solar available, it's going to circulate, run it through the heat exchanger. Because the solar loop itself,
It goes to the control. It basically they sense the water in two places, on the top and the bottom, and that's how they compute how to run the heater and the temperature inside. So
Okay, that's one of your.
it creates the mathematics that run the control. It needs 2 temperature points. So it is just a basic temperature sensor that's sending a signal up here. If you look on here, if you come here, okay, you've got an upper temperature probe, which is 137. That lower temperature probe on this one is 129. And it takes those 2 numbers and computes the tank temperature. So it's sensing 2 things, because as you bring cold water in,
Is it going to take an average then?
and it's not an average. I think technically it's an algorithm. I'm not a math guy, but it's a formula. It programs them into a formula that
But without both sensors plugged in, it's not going to work.
No, it doesn't. It would just sense one of or the other.
That's the one you were talking about that
Yeah, they got kicked off. They're right there. This was basically this just got the white thing got unplugged,
Right.
and it said lower temperature probe. Plugged it in and off it went. No, but it takes the reading up here and the reading down there based on some formula that they figured out to compute the real temperature. They plug it into a mathematical formula in their little chipboard.
Yeah, so basically our water's coming back then at 129.
Well, it's 129 at the bottom of this tank.
So in some respects, you could say our return's coming back at 129.
Yeah, kind of. Yeah, I mean that could be true. I mean, it might be.
So we're losing 10 degrees in the loop.
Yeah, it's hard to figure out. They've got so many other systems tied in here. I just walking in dry, you learn to keep my mouth shut because I don't know what they've done.
So then access to those things is like ridiculous.
And I'm willing to.
You know, I've been this access for this is actually pretty good to some of the jobs I've been to.